Hello, this is from Friday's lesson, so our third lesson on complex numbers in Unit 3. This lesson will be about absolute value and modulus part of a complex number. So starting off, we started off the class by talking about absolute value of complex numbers. So just to jog your memory, I asked the class, well, what is absolute value? And we know from before that absolute value, say absolute value of 4 is equal to 4, absolute value of negative 4 is equal to 4. But I want you to think about what that actually means. So what is the definition of absolute value? It is the distance away from 0. And what do I mean by that? So if we draw a number line, we have the number 0 here, and then when we can see from here that the number 4 is 4 units, 1, 2, 3, 4, 4 units away from 0. So the distance between 0 and the number 4 is 4 units. That is why absolute value of 4 is equal to 4. Now if we take a look at absolute value of negative 4 is here. Negative 4 is also 4 units away from 0. So because negative 4 is 4 units away from 0, that is the distance away from 0, that means this absolute value of negative 4 is equal to 4. Now using that understanding of absolute value as a distance away from 0, we take a look at absolute value of 3 plus I. Now 3 plus I has an extra imaginary part, so you might be wondering, well, then how do we figure out the distance that 3 plus I is away from 0? How does that make sense? So I'm going to go ahead and draw that 3 plus I on a complex plane. So here's the horizontal axis of real. Our imaginary axis is on the vertical axis. Our point is 1, 2, 3 over on the real, 1 up for that imaginary part. 3 plus I is right here. And taking a look at this, that means the absolute value now is no longer the distance from 0, but is the distance away from the origin, right here. So that means the absolute value of 3 plus I is the distance from the origin to the point. So it's the length of this line right here that I'm tracing over. Okay, so we're trying to find the distance between those 2 points. We're trying to find the length of that side of the triangle. So how do I make the triangle? I went ahead and just drew a line down, and taking a look at this triangle, this is a right triangle. So because it's a right triangle, we have a 90 degree here. We can use the theorem known as the Pythagorean theorem. So from your geometry class, you know the Pythagorean theorem is a squared plus b squared is equal to c squared, where that letter c is your hypotenuse. So I went ahead and just drew that triangle out here to make it a little bit more clear. So here's my triangle. And I know this side is 3 units because here I moved over 3 units to the right. And this side is 1 unit high. And notice how I didn't put I here, but I put 1 because it's 1 unit high. And I know it's on the imaginary axis, but this is 1 unit up. So I'm going to put 3 and 1. And that makes a huge difference. You don't want to put I here. Okay, so if this is 3, this is 1. How do we solve for C? We go ahead and plug those numbers in. So it doesn't matter whether you put 1 for A or 1 for B, but just make sure C is your hypotenuse. So here I have 1 squared plus 3 squared is equal to C squared. Simplifying that, I get 1 plus 9 is equal to C squared. And simplifying this, I get 10 is equal to C squared. How do I solve for that? I put square roots on both sides. Don't forget, anytime you take the square root of a square number, you have plus and minus. So we have plus and minus square root of 10 is equal to C. But remember that we're talking about distances. So whenever we're talking about distances, we can't have a negative distance. And that's why when I write my answer here, the absolute value of 3 plus I is equal to positive square root of 10. And this is the absolute value of 3 plus I. Okay. And so that means the square root of 10 is the distance from this point to the origin. Okay, so scrolling down, here's another example. And the example is, what is the absolute value of I? What is the absolute value of I? And I'm going to show you this by drawing this on the real imaginary, on the complex plane. So here's my real axis, here my imaginary axis. Since we only have I, that means we have no real part. So that means the real part is at 0, and I go up 1 for that I. So the question to yourself is, the absolute value of I is the distance that I is away from the origin, and that is 1 unit away. So that means the absolute value of I is equal to 1. So at this point, I asked the class, well, try this out. We have square root of 2 over 2 plus square root of 2 over 2i. What is the absolute value of this complex number? And this is actually a very common number that you will see second semester. But before we get there, I want you guys to try this out. So go ahead and pause the video at this point, give it a try, and then I'll go over the answer. Okay, so here's a solution of that problem. So scrolling down, just to be able to visualize this better, what I'm going to do is, what I did first was I calculated what this number was on the calculator. So square root of 2 over 2 is actually approximately 0.707. So this number right here is 0.707 plus 0.707i. So putting that on the complex plane, here's my complex plane. The point is right here. It's a little bit less than 1. It's a little bit less than 1. So I go to the right 0.7. I go up 0.7. So I'm trying to find the distance between the origin and this point here. So I don't know that it's 1 yet. That's actually what I'm solving for. But I do know that this point right here is square root of 2 over 2 plus square root of 2 over 2i. So drawing this triangle out a little bit bigger so I can annotate it better. Here's my right triangle. This is the 90 degrees. So that means this is the sides. Root 2 over 2, root 2 over 2, that is my sides. And this c value is the distance that I'm looking for. So plugging those values in, here's my Pythagorean theorem. A squared plus b squared is equal to c squared. My a value is root 2 over 2. My b value is also root 2 over 2. Squaring these two values, I get 2 over 4 because root 2 squared is 2. 2 squared is 4. Adding those together, I get 4 over 4 is equal to c squared. How do I solve for c? I square root both sides. So once I square root both sides, I get plus or minus 1. Remember, anytime you take the square root of a square number, you have the plus or minus. So if c is equal to plus or minus 1, remember, distance is always positive. Therefore, my answer is the absolute value of root 2 over 2 plus root 2 over 2i is equal to 1. And it's kind of interesting. And the reason why I chose this number for you guys to work on is taking a look at this, it looks pretty complicated with a lot of square roots and also fractions. But because it is such a special number, we get the distance of 1. And we'll see this number a lot in the future. And by second semester, you will know this number by heart. So here we go. Now that we've talked about absolute values, you might be asking yourself, well, why is the absolute value of a complex number even important? Why are we learning about this? And here I'm going to scroll down, and that is because we're going to look at a different way of looking at complex numbers. So based on what you know, I'm going to scroll down. You're going to see a lot of things, but let me explain. Okay, so the way we've been graphing complex numbers, such as 3 plus I, is we say, well, I want to go 3 units to the right for that real part, and I want to go 1 unit up for that imaginary part. So here I went 3 units to the right, 1 unit up to get to this point. So 3 units to the right, 1 unit up, and that's called my rectangular coordinate. And let me give you an analogy to understand why we're doing this. And that analogy is, say you're trying to give directions to a friend about how to get to like a place. And there's a couple of different ways of doing it. One way is you can give them directions and landmarks. Like, for example, make a right at the stop sign. Go past the gas station. Make a left at the intersection. And that's one way that you can tell someone how to get to a specific point, a specific location. Now there's another way of doing that, and that is by giving them street names. So for example, make a right on Calaroga, make a left on West Tennyson, etc. But know that these are just 2 different ways of describing how to get to the same place. No matter which way you use, you'll get to the same final point. In the same way, rectangular tells you how to, like, how many units to move to the right, to the left, how many units to move up or move down, and that's one way to get to this final point, 3 plus I. Now, when we talk about polar coordinates, there's a radius and there's an angle. So the way that polar coordinates tell you how to get to a final point, to get to that same point, instead of doing the right and the up, what we're going to do is we're going to say, okay, to get to 3 plus I, you need to go r distance away from the origin, and you want to be phi angle up. So now we have a radius, we have an angle, and guess what? We know how to find the radius, because the radius is just the modulus, what we just talked about. And how do you find the modulus of a complex number? It is the absolute value. Okay, so modulus, absolute value, and our last part, this angle, is called the argument. So this is what we'll be talking about on Monday. But remember, we have rectangular coordinate, one way to get to the point, polar coordinate, which is another way to describe how to get to that point, 3 plus I. And that is all that we talked about on Friday. So good luck on the homework, enjoy the rest of your weekend, and I will see you guys on Monday.